Hello world! Welcome back to another Almond Force video. Some of you may not know this, but I am a huge anime fan. You may have already realized this from the fact that I use anime graphics in several of my thumbnails for my videos. And my favorite anime just happens to be One Piece. Now, for those of you who are also fans of the show, and maybe some of you who aren't, we know that there are some tall-ass people in One Piece. The height in One Piece varies drastically between all the characters in the verse. In this video, I would like to utilize my cyber skills and pay my respects to Oda, the author of the series, by programmatically calculating the true average height of all characters that have been written into the story thus far. To start off, we can get a list of all characters, canon and non-canon, from the One Piece wiki site. I will be deriving all of the data that I use from this wiki as it pulls its information from the manga, Vivre cards, databooks, etc. This will allow me to streamline the process in collecting the data I need to perform the calculation. Next, I will only be using canon characters for my calculation, as the non-canon characters bear no weight in the actual story. As you can see here, I have the page for the list of canon characters pulled up on the wiki. Now let's try selecting a couple of characters for a couple of example test cases. Let's use Jinbei and the GOAT Monkey D. Luffy himself. We see that the height is listed as a value in the statistics table for both characters. However, while Jinbei only has one height listed, Luffy has multiple heights listed for each of his different debuts in the story at different ages. 7, 17, and 19 for childhood, pre-time skip, and post-time skip respectively. For our dataset, we will be using whatever the last age, the oldest age, that is listed in a character's stats, as that is the highest that they've grown up to. This is because any height under that would not indicate the character's true potential height, and we want to be as accurate as possible. The other problem we need to resolve is how we are going to pull the heights from each character's wiki page. Well, the only thing that changes between the pages is that the names from the table in the list of canon characters wiki page persists in the URL. In other words, the name in the URL of each wiki page corresponds to the name in the list of canon characters wiki pages table. So all we need to do is create a list of the canon characters and substitute the name portion of the same wiki URL for their corresponding wiki pages. That way, we can potentially exfiltrate the character's heights by looping through each character's wiki page programmatically without having to go through each page manually. So, we need a way to systematically pull the heights from each character's wiki page, whose names are listed on the list of canon characters wiki page. I'm thinking that we create two scripts. One script to pull all the names off the list of canon characters wiki page and create a list from it, and the other script to extract the heights and calculate the average from all the characters in that generated list. Fortunately, I already have a couple of empty script files created for our use. We will be performing all of our necessary operations in the Python scripting language. If we were to inspect the source code of one of the names on the list of canon characters wiki page, we can see that the names belong to a table. We can extract the tables from the web page as well as the data from the name column from those tables via the pandas and URL-lib libraries available to Python. Now you may have to install some of the libraries we use with Python's pip utility, but all you have to do for that is run pip install library name in your terminal, assuming you have your environment variables set up to run pip globally. Let's start off with a script to create a list of canon characters from the list of canon characters wiki page. We need to first import the libraries we will be using. URL-lib is a library we will use to grab the HTML source code from the website. Pandas is a library we will use to parse the tables from the HTML source code of the web page. Next, we need to actually pull the web page from the website with URL-lib's request function and store the resulting object in a request variable. We then need to store the HTML source code itself from the request object in a separate variable via URL-lib's URL-open function, along with the read function. If we print out the source code variable, we see that it matches the HTML source code we see if we were to view the source of the list of canon characters wiki page. We can now use Panda's read HTML function to parse out the tables from the stored HTML content. If we print out the tables, we'll see that there are 3 tables defined in the output. The first table contains the character names for A through M. The second table contains the character names for N through Z. And the third table is irrelevant. So we can substring out the third table since we don't need it by performing some splicing on our read HTML function to only store the first 2 tables in our tables variable. Now we need to loop through the 2 tables, loop through each name in each table, and write each name out to a file that we will be using in our next script. First, we'll need to make sure to prove that we're getting the proper data by just printing out each name to the screen. We'll do for table in tables to loop through the tables. Then we'll loop through each name from the name column in each table, because we know from viewing the web page that the field data we need comes from the name column in the tables. We can access the name column by providing it as the index to the table, and then we need to also convert that name column to a list so that we can iterate through it. Now let's print each name out as we go and test our script in the terminal to make sure we are getting the right data. And sure enough, we have the list of names that we wanted displayed. So now, instead of printing it out to the screen, we can save the list of names to a separate file. Let's open a file called names.txt for writing. And now let's replace our old print statement with the write function to append each name in our tables as new lines in our names.txt file. Now let's run our updated script. If we check our current directory in our file system, we can see that our names.txt file appears after having ran the script. If we open up names.txt, we can see that our list of names got successfully written to our output file. Our first script is complete, so now on to the real meat of this video. The script that will take the heights of the canon characters and calculate the average of those heights. Once again, we will first import the libraries we need to perform this feat. This time we import the request library to handle getting the HTML source code from the corresponding web pages. We also import the beautiful soup library so we can parse the HTML source code and have easy access to referencing different tags that are defined in said source code. Finally, we will use the regex library to find and extract the heights located within a certain tag in the source code via a string pattern for matching the format of the heights that are listed on each character's wiki page. Let's define an empty heights list for appending our extracted height values to. Now let's open our names.txt file that we got from our previous script for reading. Let's grab all the lines of names.txt and store them in a names variable. Then let's loop through each name so that we are only dealing with one at a time. I am going to add a break statement as well for now, just so we can test our code quickly and not have to wait for the script to loop through every character before it finishes. I'll have the script designed to where if it works for one character, it should work for all characters. Let's define a GET request using the requests library's GET function and replace the part of the URL where the name usually goes for the character's wiki with the name that we are currently indexed at in our loop. Let's print out our request text to make sure that our GET request pulled the data properly. And indeed, it appears that we got the source code from the character's wiki page. Now we need to ensure that the character wiki pages that we go to are valid, because some of them may not link to anything. So we need to check that our request status is 200 to ensure that we are only pulling characters that have valid wiki pages. 200 is the status code we get when we successfully send a GET, POST, or whatever kind of request. Essentially, if we successfully navigate to a page. If that check passes, we want to parse our HTML source code by converting the content to a beautiful soup object. Now we can use Beautiful Soup's find function to find the div tag that contains our height value that we want to extract. Let's go back to the wiki page for Luffy. If we inspect the source code of the height label, we can see which div tag our height is located in. It appears that our height value is located in the div tag with the data source assigned to height. Going back to our script, we can use the data source property of that div tag from the web page to parse out the contents of the div tag and store them in a div variable. Let's print out the div tag to make sure we accurately got the div tag we needed from the wiki page. We'll need to comment out the break statement, that way we actually hit a character that returns a height div tag. So let's run it now. And we can see here that we did indeed pull a div tag for a character that we finally hit across in our code. The rest of these are none because the height simply didn't exist for those characters. Now that we have that, we can use regex to extract the specific height value we want from the div variable. We will use the find all function since some characters, like Luffy, have multiple heights listed. The string pattern we want to search by is \d for digits 0 to 9, then a plus sign to designate that there's at least one or more digits in a row, and then space cm to specify that we are trying to pull just the height in centimeters. Then we need to actually pass in our div variable and convert it to a string because it's currently a tag object, and regex can't search through tag type variables. Now we will specify an index of -1, as that will grab the last age in our search results if there is more than one age listed. Since the findAll function returns a list upon a successful find, this will not affect characters who only have one age listed, as it will just reference that single element in the list. This is because lists are allowed to contain single values, which is why -1 will return the only element in the list. Before we check to see if our heights are extracted accurately, one thing we need to add is a check for when there is no height present on a character's wiki page, because not all of them have had their heights identified. If we try to run the code as is, the findAll function will trigger an error whenever we try to access the last element in the list, because if the list returns empty, our interpreter will fuss at us when it tries to access an element that doesn't exist. An easy way to mitigate this problem is by simply throwing a try except block around our height parsing code. What this does is it will try to run our findAll function on what we give it, and if it fails, our except statement will execute instead. We will make our except statement just a continue statement, which will force the loop to skip to its next iteration without executing any other code that follows after the try except block. Now that we have our error checking in place, let's see if we get the height strings that we wanted. I'm going to go ahead and move the break statement into here, as we will just be testing one success. That way we don't have to sit here and wait. And then let's also add the print statement in. We get 195 centimeters, and that belongs to, what we can do is rerun this. With some extra code here that will print out the name corresponding to the height that we have printed. So let's try that now. And we get Absalom at 195 centimeters. If we go back to the wiki and check that Absalom is at 195 centimeters, we see that we indeed pulled the correct height for this character. Now we will split the value that we just indexed by the space in between the number and the CM and grab the first index from the resulting split array. That is because we only care about the number value. The extra CM portion was only useful to us as a unique specifier for locating the heights within the div tags. Let's see if we just get the number value string now instead of the height and unit string that we had previously. And indeed we do. We can see that we get just the 195 here. We can now append the height to our heights list that we defined earlier, but we need to make sure we convert the height to an integer value first because it exists as a string type value currently as it stands. We need to be able to perform mathematical operations on the height values, so they must be integers for us to be able to do that. For a proof of concept of what we have so far, I'm going to remove the break statement we added earlier and just let the code run for a little bit. I'm going to press Ctrl+C to stop execution as we get the idea now and don't need to keep it running. As we can see here, we're getting all the characters that have their heights identified by the wiki. Now that we know we are properly getting the height data we need, we can move on to scripting out the average calculation. We will define an average variable and take the sum of the heights from the heights list divided by the length of the heights list. That is how you would normally calculate the average for any group of numbers, but this is how you would normally do it in Python. The sum function takes all the elements of our array and adds them together automatically, and the length function returns how many elements are in our array. But we also want to calculate the feet and inches as well, just so we get an idea of the average height in layman's terms. To calculate the feet, we just need to take the average and divide it by 2.54, and then floor divide that by 12, as the feet value won't be a decimal value. This is because there are 2.54 centimeters in an inch and 12 inches in a foot for those of you who are on the metric system. However, I'm going to actually multiply the average by 0.393701 because 2.54 is a rounded value and isn't as accurate as I would like it to be. 1 centimeter is approximately 0.393701 inches, so this should be accurate enough for our calculation. For determining the leftover inches, we want to do the same thing we did to calculate the feet, but we are going to use modulo rather than floor division. The modulo operator will take our first operand and divide it by our second operand, and then give us the remainder from the result. We are also going to round it to 2 decimal places just for readability purposes. Now we can write a statement to print out our average height calculations. We're going to go ahead and round the average that's currently in centimeters to 2 decimal places here, just like we did with the inches for better readability. We have to make sure to convert all our calculations to strings too. Otherwise, Python will throw an error as all values in the print statement need to be the same data type if we are attempting to concatenate them together in the output. Let's take one more glance over our output and make sure the format's on point. Now, one thing I noticed before we execute this script is that I forgot to convert the height here to an integer. And if we don't do that, like I said before, it will remain as string values, and when we get down to these calculations, it'll error out because it can't perform these mathematical operations on string data types. So they have to be integers. And I think we can finally run the whole script. Now, this will take a while as there are a lot of characters it has to pull heights for, so I will get back to you when this is done. Now that the script has finished executing, we can see our glorious result. The average height of the one piece verse ends up being 347.57 centimeters, or 11 feet and 4.84 inches, essentially 11 foot 5. Picture this, the average human height in our world is about 5.6 to 5.7 inches. So this is around double the average height of a human in our world, which is insane to think about. It just goes to show you that the One Piece verse be built different. Anyways, I know our Lord and Savior Goda probably won't see this video, but if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.